Well, we're live again. CNBT 1311. This is the third video, chapter 4. Light gauge steel joist. Light gauge steel joist are cold formed. You can read about this up here, in here. They have a wide range of finishes and gauges and strengths and spans. They hold there's some advantages to it. Termites don't like to eat it. They're lighter, they're more dimensionally stable than wood. They're cold formed. In other words, they'll come out on a rolled sheet and they'll run through a die. There's a company that prefabricates residential walls and roofs and structures with cold formed joist or studs or members. And if I can find that video, and if they're still in business, they sell a whole system. I'll post that on D2L. You've probably seen these used as wall studs also, but since we're in the flooring system, we're going to talk about joists, but it's the same deal. United States Steel used to have a whole manual that sent to engineers on using these for lightweight structural applications. Again, they can be lighter than wood and more dimensionally stable. They're resistant to fire damage, although all structural steel has a limit for the heat loading. Once it reaches a certain temperature, depending on the grade of steel, it loses its strength and will begin to sag. So even though it won't burn, it will lose its strength from heat and sag. All right, they can easily be cut. They can be cut with regular skill saws or sawzalls, and they're assembled with simple tools. Most of your connection joints with these will be screwed, self-tapping sheet metal screws, and they come in various depths from 6 inches to 14 inches in 2-inch increments. Flange widths are different, and the gauges are 14 through 22. You can either punch the holes yourself, or they can come pre-punched for running wiring and plumbing, depending upon the depth. Again, running your electrical is one thing. Running plumbing through this is another. And of course, HVAC, your ducts are going to be bigger, so they're going to have to run in between here. That'll have to be a consideration for your design. Rules of thumb, again. Rule of thumb. You need to consult the manufacturer and your engineer. Rule of thumb for estimating your joist depth is span over 20, but that also depends on the gauge of the joist. All right. But generally a 6-inch joist would go from 10 feet to 14. But again, that depends on the gauge of the steel. The lighter the gauge, the flimsier this is, and the propensity for this stuff to want to roll on you unsupported. So, but we'll get into the lateral bracing later. He does mention bridging straps across here. Best thing to do is stay away from the needs of those. So watch your spans. Again, work with your engineer. Web stiffeners, you'll find those mostly on the end. These can be prefab clips that are screwed in on the bearing, because this will be your greatest point of bearing load if this is a uniformly loaded beam. Reinforced concrete over metal decking or wood panel subflooring can be done. Again, you need to watch your loading. That's between you and your engineer. Overhangs can easily be done, and if these are actually manufactured on site with an extruding system, the company I referenced before, again, I'll go dig through my files and see if I can't find that company, and But they use a CAD system to design the length and depth of these things, and then it's extruded through a machine. You get that, theoretically put that machine on a trailer and take it to a job site. What they've done, that company, is they've just prefabricated all of this and trucked it out, which saves on-site labor. Now, if this is a masonry, reinforced engineered masonry wall or cast in place concrete wall, obviously we know this wall is good and shear in this direction. Depending on how you connect, again, the devil's in the details. The decking on these steel joists would indicate you got a diaphragm up there. So again, there's a lot of freedom of movement in this. Now here's a detail of using the coal farm steel joist as your wall system. You can do it as non-structural or structural. A lot of your interior walls in commercial buildings, it's non-structural, and these are super light gauge. But they make heavy gauge for structural, and there's some advantages to that. I have a friend of mine that's got his nice residential home up in Montgomery County. He doesn't have a single wood stud or a single wood joist in his house. It's all metal joist and metal studs. The construction of this is very similar to wood. You won't be using nail guns, but you'll be using screw guns and self-tapping screws. You may need bridging depending on the span and the rollover. Again, you need to check with the manufacturer and your engineer, okay? And they're talking about the rotation for lateral displacement. You load this thing and it's going to load off to the top and it's going to want to roll on you. Diaphragm will help with that, and so will the horizontal bridging. All right, here's details. Steel studs going on a continuous runner on a double channel with a clip angle, and these are supposed to be light gauge steel joist for light framing. Another example of the reinforcing at the end connection. Here's your end runner, your perimeter closure channel that caps all this off, and how it's attached to a concrete wall. Double or nested joist, where they're putting them back to back. There's your enclosure. There's some more double nested joist. There's a reinforcing clip there. All right, so that's about all there is to the lightweight steel joist. You're treated like everything else. They're just not going to carry as much load as a hot rolled structural steel member or a truss, K truss or whatever. There's a floor pan detail. It's the same deal. You just have to know your medium. There's another detail of a pocket, an inset pocket cut, ledge cut, and a concrete wall. Wood joist. Wood's the least strong of all of what we've talked about: concrete, hot rolled steel, or cold formed steel. Although you can build these up to wood girders and wood panels and glulam beams. So fire resistance is an issue with wood, and susceptibility to rot and termites. All right. So here's an end section of a wood joist floor. There's your floor or your roof. There's a ceiling, if that's a subfloor up on top, and the space in between. So here's where you'd have to run your utilities, your electrical. Of course, electrical you can drill through here and run your wire, which is what they mostly do. But for your HVAC ducts, again, you've got to size your ducting. If you've got a 12-inch duct and you're using 2x12s that 12-inch duct will not fit in here because the 2x12 is not 12 inches deep. It's less than that. If I remember correctly, a 2x12 is 11 1/4 inches deep. I always check that because at my age I don't want to run on memory. Joists are spaced on 12-inch centers, 16 or 24, depending on the loading. Do not go past 24 inches. If you can afford to put your wood joist on a 12-inch centers or 16-inch centers, depending on the load. If it's a heavy floor, you might need 12, but your walls are generally 16-inch centers. It would be nice if you could at least do your joist, but most residential will run 24 inches because they'll throw the plywood up there, and unless it's a cheap, crappy built home and they're using OSB. I hate that, OSB. We'll talk about that later. All right, so ceilings may be applied directly to your joist. If this is residential and this is sheetrock, this is going to be 5/8 inch sheetrock in the ceiling. It'll be 1/2 inch on the walls. There's no extra charge for that. All commercial sheetrock will start at a minimum of 5/8 inch. Let's get rid of all that. All right. Okay. And again, you're required to read all this stuff off to the side. There's not a whole lot of reading. You got details. You are in a graphical medium. You're designers. You're architectural designers. You may need to double gang these joists. And like anything else, there'll be a need, maybe, at some point, for some diagonal bracing in here. That can either be wood or it can be fabricated metal. They make special metal rods that will nail into the side or screw into the side of these joists to keep them from rotating. All right, end joist may be doubled, and you might want to do that. You may need a center one that's doubled. Depends. This is a good detail for an opening, whether it's for a rooftop unit or TU or any other kind of opening, or putting a ceiling fan in. Not a ceiling fan, an attic fan. They don't do that much anymore, but attic fans were cool. I loved those as a kid. Man, you could exchange the air in the house, especially after you got let's say you got a norther in and it was like 90 degrees and all of a sudden everything got cool. And when the sun goes down, you can open those windows and for about 30 minutes run that attic fan, and the entire house would be fresh air and it'd be cooled down. Forgive the dog. He's after some booger. All right, sheathing, wood. Again, we talked about that in another section, I remember. You glue and screw this, or use ring shank nails with nail guns. You could turn this whole thing into a diaphragm. And again, as you probably already figured out, I'm a big diaphragm freak. There's no reason to put structural elements on top of structural elements and not make it a structural unit. It just seems to me to be illogical. But that's me. Now, if you're going to make this a diaphragm, you want to cookie cutter or stagger your plywood. So like this might be a 4-foot section, 8, and then this section would run this way, and then this section would run another way, and you'd stagger them out. This is really a poor drawing, okay? That way you cookie cutter them, and you're not laying them all in the same direction. So you've got different directions of shear in your diaphragm. Now, if you did a good job of gluing and screwing, you could probably lay them all in the same direction and get over it, especially if this is tongue and grooved, engineered, American Plywood Association structural plywood decking. But still, you don't want your joints in the same run. You'd have half sheet them. Which is a disadvantage of wood. as opposed to steel, because once you glue the steel together with electricity, we call that welding. It becomes one piece. All right. He talks about that. So he's talking about this being a diaphragm. Um, I just naturally gravitate to that. All right. Wood joist again. Here's some more rules of thumb and details. Here's your cap joist, your end joist. Um, that boxes it off. That's the header. Your end joist may be doubled. You're going to have a fascia joist over here. Be a double plate on top. And this is all bearing connections, unless you're going into a structural wall and you're going to eat up your elevation with a corbel, and then you set that on a corbel. Most people don't do that. I've seen some old wooden industrial buildings down off of Washington Avenue that were like that. They were wood joist against engineered masonry walls or engineered concrete walls. But they would normally just set them on top anyway. So you got a double plate up on top. Here's a single plate that's nailed into. They make fabricated metal clips that tie into here. If you're on the Gulf Coast, the code down there may require you to use what they call hurricane clips. It's nothing more than strong tie metal side clips for the joist, and you have to check your building code. The joist span is like all other spans, are related to the magnitude and applied loads. Here's some rules of thumb. Again, this is a rule of thumb. Your mileage is going to vary. All right. 2x6 is up to 10 feet. 2x8's from anywhere from 8 to 12. Again, depending on the spacing and the loading. 2x10 can go up to 10 feet to 14. I think you're stretching it at 14. Quite frankly, but yeah, 2x8. This up here, this on the end. Again, if you're at the end of this rule of thumb, you need to go up one if you can afford the depth, extra depth, and the height of your structure. All right. Theoretically, a 2x12 is 12 feet to 18 feet. Your mileage is going to vary. Get with your engineer at the American Institute of Timber Construction. Rule of thumb for estimating your joist depth is a span over 16. You can compare that to some of the others. I mean, wood's a good material. It's been around for a long time. Joist deflection should not exceed 1/360th of the span. Okay, your joist deflection. Your stiffness of the joist framing, this means nothing to you, that deflection. Your engineer will calculate the deflection. What it's saying is you put your length of your span in inches up here, divide it by 360, and that is what your maximum deflection. And again, that depends on what kind of, if this is a floor up here, like second floor, and you wanted to put some kind of floor covering up there, you might want to watch the deflection of what that floor covering could handle. Let's say it was marble or tile in a bathroom. Well, even this might crack it, right? So again, you've got to look at the whole system. If the overall construction depth is accessible, deeper joists are spaced further apart are more desirable for stiffness than shallow joists placed more closely together, unless you've got a diaphragm up there. And again, your mileage is going to vary. You get with your structural engineer and look at the cost benefits and cost of going one way or the other. Now he threw the laminated veneer lumber joist in here. Okay, of course you're going to get with the manufacturer who comes up with the lam beams, the glue lam beams, or joist, or if they're wood trusses. There's an apartment complex being built not far from my house right now, and they're using prefabricated square wooden floor. I'm gonna call them trusses for lack of a better word, because that's what they are. It's like a Pratt or a Warren truss. And now they've got wooden members coming across here. They've got metal tie plates that are nailed here, prefabricated metal tie plates. So these came from a manufacturer, and that manufacturer's got an engineer, and he'll tell you how much load these will carry over what span. They come in all different shapes and sizes. Some of them are complete roof pitches. A complete roof covers the whole load-bearing walls from exterior wall to exterior wall. All right. Building consists of wood, metal, or cross bracing for full depth blocking. All right. Some codes may want you to come in here and put fire blocking in here. They may want you to come in with this is a big wood panel that's in here, and that would be for fire blocking. The idea behind that is if there's a fire and it breaches this fire barrier, and the fire comes up into here, or the fire is in between the blocking, then this doesn't become a chimney, and the fire spread throughout the entire structure. We see fire blocking in walls. So some building codes will vary. Well, they'll all vary, but if the depth is 6 inches or more times its thickness, you're going to need some kind of blocking and bridging. But again, this is your engineer and you working together on this. Maximum diameter is 1/3 the joist depth. This is talking about to allow plumbing and electrical lines to pass through floor joist. Cuts may be made according to the guidelines illustrated above. I wouldn't do this. I'd get with your engineer. I mean, if it's a main load-bearing joist and you go punching holes in it for a sewer pipe, a 4-inch sewer pipe, depending on where in that joist you're cutting that hole, you may be right in the middle of a moment or a shear for that loaded beam. I wouldn't do it. So again, you need to check with your engineer. If it's a residential structure, no one's even gonna ask. They're just gonna punch holes where they need to and hope it works. And we've seen that. All right, wood joist framing. Okay, here's let's say this is a basement wall or foundation wall. Your end joists bear entirely on the sill plate. That's a sill plate on this wall. There's going to be insulation, and you want insect infestation. You may even have a bug lip in that wall. So here's a concrete wall, and there's a little, what we call a bug lip. And then your J-bolt comes in here, and then your sill plate comes up here on top like that, and your bolt, and then you start your wall framing up from there. Now what goes in here? Piece of flashing, one piece of flashing there, little Z-stripper, and then when you come back in here and you start your wall, you might put another flashing depending on how well you want it insulated or flashed. And then your wall covering would be over on the outside if it's siding or hardy plank or air gap, and then you're going to set your brick. If it's brick, it's totally different. You're going to have several of these. You'll have your brick ledge and then maybe a bug ledge. If it's a steel building, it'll be a bug ledge like this. So anyway, again, your mileage will vary depending upon your material discipline and everything else. The medium you're using. Okay, this is your wood joist. Okay, and This is 1.5 inch minimum bearing for the toenail, and he says use 3 8D nails or 8-penny nails. Your mileage is going to vary. But you're going to tie the end with this. So if you're going to structurally tie it with your end rail or your rim joist, then you basically built you a box. And then with the right subfloor, if you use your plywood as your structural element for a diaphragm, then these 8-penny nails just hold these in place while you're finishing the assembly. Once all this gets glued and screwed or glued and nailed and put together, and it's one big giant wooden box. Here's an example of a prefabricated metal anchoring system, sill plate tie down, for wind loading in certain conditions. Wherever you're at, the code may require these at every joist, at every stud, or periodically. That'll be according to your building code, and it all ties back to some kind of lateral pressure from either wind or earthquake or you name it. Best thing to do is use pressure treated lumber for all your sill plates. It's against the concrete, it's closer to the ground, so you want to use pressure treated. And if this was the first floor and the landscaping was close, I'd probably spend the extra money and have my rim joist pressure treated also. If it's going on a pressure treated sill, there's no reason why this can't be pressure treated. Be money well spent up front. And get ground contact pressure treated lumber, not just pressure treated. Make sure it's certified for ground contact. I don't care what any of this book says. All right. Depending on what seismic zone, he talks about that, so that's a part of a code. Your mileage is going to vary. I'm telling you, we're not in a seismic zone down here. We're in a wind zone, hurricane zone. And the closer you get to the coast, you've got other requirements. And your structure may not be able to be insured unless you build it to a certain code. Even though it may pass the local code, there may be an insurance code or a hurricane code. You'll just have to research it. Here's an example of solid blocking. Now, fire blocking in a stud wall would be, let me get my other pen. Let me see if I can find it. There it is. I think I'm getting better at this with this pen thing. Okay, this would be an end deal. It's going to come across, and you're gonna toenail the fire blocking into your vertical studs. It'll just be a toenail. This blocking again keeps the wall cavity from being a chimney in fire, because if there's a fire, hot air rises and it also accelerates in velocity. That goes back to Bernoulli's equation and Boyle's gas laws as they expand. And this stops the flow of hot gases, hopefully long enough that you can exterminate, get a fire suppression team in there to exterminate it. It keeps it from flashing through and burning as quickly. Doesn't mean it won't burn down, but we call this fire blocking. And it also acts as lateral blocking. Right? It stiffens this column up, and that's all a wall stud is basically a column, whether it's a 2x6 or 2x4. If you can afford 2x6 walls, I would use 2x6 structural walls. You can put more insulation in there, but that's just my opinion. All right, and that's the opinion of a lot of people. There's some custom builders that are no longer built using 2x4s for their exterior walls. Now, these aren't the chuck in the truck dudes in most of these track houses. These are custom home builders, and the minimum wall thickness is using a 2x6. Good ones will talk to you with using metal studs. If I ever build a house, actually get to build one from ground up, for me, it'll be metal studs all the way around. Um, I live in a 50-year-old house. It was built in 1973. Um, so, by 73 standards. All right, so we want to provide at least a half inch, according to Ching, and that's not a bad idea. That's pretty much a rule of thumb for an airspace if you're butting up against a concrete wall with a pocket, okay? And you're going to need to shim, again, to level this beam, because we know that not all this is going to be dead nuts on, no matter how good your engineering is. And there'll be some settlement. After this concrete's poured, there will be some small settlement. And this wood is not dimensionally stable. So, so you'll have to shim to get this level. Let's see. Here's a term for you, a pilaster. It's the thickened wall to form a pilaster. A pilaster is like a column sticking out of a wall. Here, let me draw one. Let me draw it. Okay, a pilaster in plan. Let's say this is the wall. That's the outside face of the wall. This is the inside face of the wall. Boy, that's an ugly looking column. That carpenter, that concrete guy needs to be fired, don't you think? Okay, this thickened piece is called a pilaster. It's basically a column stuck with a wall. Now this wall could be concrete block or it could be reinforced concrete cast in place. So it could be CMUs, and you would build the pilaster out of CMUs and turn a CMU block this way and staggering them in and then tying them across. And that's all about masonry, and we'll get into that later. But the pilaster is an external column. It stiffens the wall. So, and the building codes will tell you so many feet a unstiff or unreinforced wall will have a pilaster. American Concrete Institute will recommend spacing on a load-bearing concrete wall. You'll go so many feet, and you'll need a pilaster. And so will the masonry code. And again, it depends on the code you're building under, and your mileage will vary. I know that sounds like a cop-out, doesn't it? Your mileage will vary. Well, it will. You ask anybody who's ever been in construction or engineering for any length of time. Yeah, just because you did it on one job doesn't mean it's going to happen on the next one. Okay, let's try to be drafty, architecturally drafty people here. Okay, all right, there's your section A through your pilaster looking down on it. Okay, all right. Okay, all righty then. Wood joists may be supported by wood or steel beams. Well, no kidding. Now, these are those strong tie clips. Strong Tie is a company. They've been around for a long, long time. You can go to big box stores like Lowe's or Home Depot and look at their entire catalog. They've got stuff that you can build a geodesic dome with, little plates, connector plates, all kinds of gizmos. These are joist hangers, okay? It's hard to weld. You can't really weld wood to one another, okay? You can glue it, but it's really not a good joint. I'm being silly, but all you do is you set the joist in this joist hanger. These are nailed or screwed, and then once the joist goes in there, then you nail it or screw it from the side and go on about your business. Some codes require you to use these on every joint. Some codes will require you to put in metal strapping. Now, some people call this hurricane straps or hurricane clips. You may need a ledger underneath here to help level all this up while you're putting all your strapping in. Now, just because he says toenail with a 10D to the beam doesn't mean squat. Okay, or 316D. That's 16 penny or 10 penny nails. That doesn't mean nothing. This is your structural engineering, your building code. Your code may say For floor joist, it's all going to be X, and you will do X or you'll get red tagged, and the inspector won't approve your job. All right, your mileage is going to vary. Yeah, you like that, don't you? You can use wood scabs to tie these across if the code allows you across a metal beam. Um, let's see, he really should give you a side section detail in here. These are wood joists going into a, um, a hot rolled steel beam section. Okay, you come in here and you lay down a a nailing plate or a sole plate on the lower flange, bolt through it, or Hilti nail it. You can nail power nailers that'll go through steel if the flange is thin enough. Most secure would be bolting it like that. Then lay your joist in there. You may have to clip the end of the joist to get underneath here, and then toenail that. And he's showing you an example of a strap to line all this stuff up while it gets toenailed in. And then your floor decking goes across this. All right. Here's another example of going through the top flange of a beam, and then your scab, your side scabbing. Okay, I don't know if he's not calling it a scab. It's a lap, but it's still a lap joint. And again, this is your sole plate or your nailing plate, whatever you want to call it. If it's the bottom plate that the stuff sets on, I always call it a sole plate. Or you can call it a nail plate. It's all the same. Potato, potato. Again, here's a metal strap. Your code may require that. It may not. I think we beat that up enough. Let's move on. How we doing on time? 37. Man, the time blows, doesn't it? Okay. I think this has 40 pages in this chapter. Yes, it does. So we'll probably have to make another video. Here's a good detail you can think about. Now, is this really a structural joint? Yes and no. Okay. This wall would obviously be an interior wood stud framing wall. Why? Because look, here's your subdecking, right? All right. You certainly don't want your subfloor, if this was an exterior wall, to have your in panels. You want all that as hard and fast as you can to your structural system, and then run your diaphragm up to that. Okay. Now, an argument can be made with your engineer that, yeah, run that bloody subdeck all the way out. We're going to use treated plywood on the outside, first run all the way around the building, and with a treated edge cap or edge board, ledger board, and then set this on top of it. And since this is an exterior sole plate, maybe we want that treated and the rest of this non-treated. Okay. Again, your mileage will vary. You have the freedom as long as you can afford it. All right. And most of the time, this would go on a sole plate and framed up on the exterior, and then they drop the subflooring in, and it still works as a diaphragm. All right. But generally, this detail would be for an exterior wall. You've already got your floor plate in, and if you're going to make the whole floor diaphragm, then you set this on top of that. But then, if this is 1 inch, then these studs that would be normally standard height studs for a wall would have to be custom cut, right? So if you're buying the studs as a bundled stud, pre-cut stud for stud length, going on a seal plate, standard seal plate, and a double top plate, you're probably not going to want to do this detail. You want all your walls up, and then go lay your floor decking in and turn that into a diaphragm. Because what is this? This is a piece of floor plate, really, that's nailed to the joist. So it's all going to work as a diaphragm. But if you do this kind of detail, these joists have to be shorter than the normal exterior wall joist. Okay? Unless you're allowing for the total height. So if you did an exterior joint, exterior wall, where, well, Ching, you cheated us. We don't have that here. Well, anyway, if you did an exterior wall where this was not sitting on the subfloor, then you would have the thickness of that subfloor difference in your height. So be careful with that. And again, there's nothing wrong with doing it either way. Here's an example of fire blocking in your floor joist. That blocking serves as lateral bracing, and they are really, really spinning a lot. They got 2x2 ledgers underneath there to hold the blocking. Well, it gives you something to hold to, but I mean, nail to there instead of toenailing it in. But you could go back up here and use these strong ties if the code wanted to. You can use that for your blocking also, as long as the blocking will fit in between where it's supposed to go, right? Double joist space to allow for passage of mechanical services. So what he's showing us here by double joist is you're making this a beam. We're going to make this a structural beam. That's why he's using the 2x. And this allows you to then in nail your blocking all the way down here to turn this into a beam, a box beam. And that's a box beam. And then the spacing can be wider for a floor duct, HVAC duct or something coming through here, or piping, okay? Another way of doing it is bundling them together. If you need to, you can cut plywood and stick in there and glue lam the thing, make it on site. There's all kinds of things you can do. Another example of wood stud framing, there's your sole plate, your subfloor, there's your fire stop, okay. This is an overhang for a soffit. This might be an exterior bearing portion of joist, no portion above. Non-bearing portion parallel to joist, no portion above. These joists are not supported in this detail, so it looks pretty funky, doesn't it? Okay. Let's hope that they're being supported out here on this end here. And this is an interior wall. If you sent that to me as a structural detail, I'd fire you. Let's see. Wood joist framing, 31. Here's an example of using the hangers to build you a overhang on an exterior porch or wall, or maybe this is a balcony, although it's not extending very far. I don't know, 24-inch balcony, but could be a good way of doing an exterior overhang for an exterior door. Another way of doing something, another way of detailing it. It's a variation on the same theme. What's he talking about here? Floor opening, that is if stairs. Okay. Yeah. Now, assuming you're going to build a set of stairs up through here, although this would have to come from here up, so you have a landing up here. Here's your strong ties, your joist hangers, and a double joist. You can see that. These are your tail joist. What else? What did he forget? No, there's a post. Okay, here's an opening, like maybe it's an RTU unit or for, again, an attic fan. You want to reinforce it with double and then use your joist hangers. Okay, this is carrying most of the load in that direction, and then this is picking up the load from these, and it transfers there and there. Okay, now these are called trimmers because you're trimming out an opening. So that's a term that is used as for for opening and headers in spans of greater than 4 feet. Oh my goodness. Double trimmers. Don't be surprised if you're working around carpenters, they call it something else. All right, let's see. Let's go ahead and stop this at, we got 8 more pages to go. So we'll do a 4th video. It'll be a shorter video, unless we get deep down in the weeds on the combined subflooring. I know this is painful, but I'm the one that has to go through all of this too. So we're in it together. Remember, we're building this plane as we're flying it, because this course was given to me less than a week before it started. All right? Okay, so we're at 45:41. We'll see you on the next video.